Welcome everybody. Today we're going to talk about ProxySQL and the use cases that we think to share with you, and maybe we can open up some discussions and have some ideas about it. So who we are. My name is Alkin. I work at Percona as a technical team manager, and I run a global operations team. And here's René. René is a MySQL expert and SRE at Dropbox, and he's the author of ProxySQL. Okay. So we want to talk about the use case scenarios, but we also want to mention the ProxySQL users. ProxySQL is an open source project, so it's up in the GitHub, so people can actually download and use it without subscribing any of the newsletter or anything like that. So it's open. Basically, we don't know who's using it. But there are some companies who had actually agreed to share that they're using it. There are some companies that we know they're using, but they're not supposed to share it. So because of some legal stuff that they're not sharing or letting us share their logos or names. So is there anybody in this room who's using it right now or maybe testing it? Okay, so we got some testers and not in production yet. Okay. So we still have some people coming in. Okay, let's continue. So we are on almost at towards the end of the conference. We had a couple of sessions. The reason that we put together these, they were held already on Monday, the tutorial. So you can actually download the slides. The slides have the GitHub link for a Docker image to play around. If you can, go ahead and find that in the Percona Live site, and you can actually practice some of these case scenarios that we're going to talk, because that was a pretty good tutorial. Thanks to David and Derek also for their contributions on putting that tutorial together. So you could do that. Also, the other sessions that was already held yesterday, ProxySQL to improve high availability solution by Marco. His slides should be up also. Marco has numerous blog posts. So I would suggest searching and finding Marco on the internet and reaching his blog post, because he does a lot of benchmarking, research, analysis, or the case scenarios that's really interesting that he investigates, and he reports a lot of issues to René, and we have a lot of discussions on that. Also, some of you might be knowing that Percona XtraDB cluster 5.7 is shipped with ProxySQL. So there was another session by René Cannaò yesterday. You could reach their slides. Both of them are still here. If you have PXE cluster and wondering what's happening with ProxySQL and PXE, you can actually find them in the booth area in the Percona stand. So there was another discussion. We did this back in Amsterdam also, ProxySQL and orchestrator integration with Shlomi. Again, thanks to Shlomi also, and that was held. There are some notes about that, which they will be turned into a blog post and shared, I assume, very soon after the conference. Okay, more sessions. That was the sharding. So this is sharding is another use case scenario that we're going to talk about a little bit today. And again, you can find detailed information from Marco in his blog post, also his slides. Unfortunately, Christoph is having his session now on another room. So since you're here, you'll be missing his talk. He talks about all HA solutions and the load balancers, and he looks at them. Thanks to Christoph. Christoph works at several nines, and several nines has done some testing and implementations in ProxySQL for their cluster control application. There is another session that is Thursday, which is next one. You can still have that with the data masking and with ProxySQL. So thanks to Fred and René for putting that together also. It's very interesting topic, actually, if you guys are interested in data masking and hiding some of the data. So that's tomorrow. So what is ProxySQL? So we're going to talk about some of the cases, but some of you may know, some of you may not know about ProxySQL. We want to mention that it's a proxy layer of another tooling for the MySQL topology. So basically, it is protocol-aware tool that you put between your application server and the database server to control over it. And it's an open source tool, and it allows you to do numerous things that you wouldn't be able to do it normally. We had a lot of talks about data, knowing more about data, so this is another way of getting into insights into what's going, what's hitting, and what's using your databases. So I hope some of you already know about ProxySQL by now, because it has been a very hot open source tool for the past couple of years, and it's evolving by the discussions we have, by the demand we have, by the questions we get from our customers or our friends. It's actually evolving into I would say a better tool than some of the initial ideas that we had. So thanks to, again, René for putting those together and hard work behind it for many hours trying to implement those. So we actually think there are a couple of reasons. So we should have a reason to have a proxy layer that is actually protecting or helping your database operations. So one of the reasons that we would suggest using ProxySQL or proxy layer is to improve your database operations. So I assume many of you are either software engineer or a database administrator, and you actually deal with databases a lot, and you know the challenges that we have. As it grows, the clusters become bigger, so we want to have more control over. Of course, MySQL is also evolving with many tools. We have friends from Oracle, so we saw that there's a lot of improvements in the Oracle database, but MySQL database, but improving database operations can help using ProxySQL. So the other thing is actually, which is related to improving database operations, is to actually understand what is happening in the database. So by putting ProxySQL in between the application server and the database server, you're allowed or able to collect more data about the database actions. So this is the user's information, threads, the queries that are passing through, hitting the spikes that you want to investigate. So there's a lot of metrics inside the ProxySQL that you can investigate. And actually, on top of that, not only investigate, see it. Unlike some of the other proxies, you can actually make modifications and make a change in the operation. So you can actually do a significant impact by just touching the proxy layer without touching the application, without making any code changes, without making database configuration. You can actually make some changes in that layer and allow you to maybe fix it later on, improve the operation by changing the code or the queries, because we know that we often find bad queries in the database. We find slow queries in the database, but it's highly unlikely that you can fix them overnight. Things take time. The deployment cycles are slow. Then you have to go back and make changes. So there are some options to do that. So also that allows proxy layer allows to protect the database. So if you see like a spike or something like that is hitting, it could be some job that was forgotten or something that is coming from the internet, or internally some of the users may not be aware of they're hitting the production database. You can actually you can block them, change their permission or the way that they access the database. So it's basically you can actually protect your database by having the proxy layer. And moreover, we have many high availability solutions and options right now around MySQL topologies, clustering solutions, some of them. So this is another one that you could use it. with a smaller footprint and easy implementation, because the other solutions have pros and cons. They have their own caveats and difficulties, I would say, because depending on the workload, plus depending on your database design and the size, it could be very complex. But if you have a proxy layer between the database and the application server, you might be able to implement a quick, high availability solution by using this tool. Again, by combining all of these and some of the other features that we are coming with this, it'll give you a more robust database administration ability. Okay, so for the ProxySQL highlights, we divide that into 4 different categories for the features. So it allows the features that it provides. One is the scalability. So we actually think that is actually number one of the big features, but number one priority for me actually is the scalability, because oftentimes if you don't have to scale, that's not a big problem. We have a lot of other workarounds. As a DBA, we can actually scale in a different way. So the other thing is the high availability that I just mentioned. This will allow you to do some of the high availability options faster than you would do it in different tools or different techniques. It also has an advanced query support. So just like I mentioned, it is not just a dummy proxy layer. It's also protocol aware. It has its own tool with the manageability, and then you can actually have the console of ProxySQL will allow you to do some query-related operations to the database. So if we drill down on some of these, which we will go into more deep dive, and maybe if we have some time left, a demo at the end. So on the scalability side, what we have, what are we thinking on the, how do we scale on the connection pooling and multiplexing is one of them. So basically adding a connection pool layer to the database server is a great idea, so that you don't actually randomly pick connections, and that's a very big overhead. Especially the high traffic databases will suffer from multiple users coming and going. And if we have the proxy, it'll actually have only one connection or a couple connections, or you can actually do open multiple connections to allow n number of customers, like accessing your database. So that's basically the users will have less overhead in the database. The other thing is the read-write split. So by nature, we have MySQL replication. So you can basically easily split your read-writes on those using ProxySQL. This is something like a no-brainer to have, not to have one in the MySQL, because you have the native replication. You can have the slaves and then send your reads, and then use ProxySQL to do that read-write split with to allow higher workload on the databases, so the throughput will be higher. So this is another thing that read-write sharding. Like I said, there's a deep dive from Marco's talk and a blog post about it. We'll talk about that a little bit, but there's a way that you can basically shard your data if you put ProxySQL in between the application server and the database server. Okay. So we continue on the high availability. So basically, if you actually use ProxySQL, you can basically do a failover, and it can actually understand the reads and writes, and it can actually fail over the servers behind the host groups that you design. This is actually it doesn't basically handle the promotion of the slaves. You would have to use it with other tools like MHA or Orchestrator or something other than that, or your own tooling. But it'll actually allow you to basically promote different servers in a read-write balance. So the load balancing can be done. Also very easy to scale doing load balancing on some of the servers that you could put on behind the ProxySQL. Also, it's a cluster aware that, like I mentioned in the PXC, we're already using it, and that is going to be more common with the 5.7. Okay. So we go on the next set of features in the advanced queries. We have in ProxySQL we have query caching, query rewrite, and query blocking. So the query caching is that there's a way within the ProxySQL settings that you can actually define certain queries that hits a lot, and you don't have problem caching them. It will actually allow you to cache those queries before hitting the database. And the other thing is a query rewrite. So I need to mention this one. This is one of the first ideas that the ProxySQL's why the ProxySQL was born. René and I was talking about that because we would see bad queries in the database and we would not be able to do anything. And so we were saying, you know, it would be really good if we could actually do a rewrite on this on the fly without changing the code, and maybe we can actually get the developer or the application fix that later on. So there's a way to rewrite the query as you identified. So since you can actually interrupt the queries in that proxy layer, you can actually block also those queries. It's like a database firewall. Are we doing it at the time? Okay. 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 So from the query handling with the queries hitting the proxy, you could actually do a mirroring. So this is actually a pretty cool feature for a bunch of things like auditing, analyzing, or cache forming. You could use there's different requirements sometimes. So one of the other thing that we face often is the upgrades and the different versions of MySQL. Even if it's a same release, same version with the patches and other stuff, you can actually do the mirroring and do some analysis on the mirrored server that you wouldn't actually impact your production database, and then actually do some analysis, collect some data, what's happening over there. You can make modifications to the configuration parameters on the mirrored server and try to understand better using this. Query throttling and query timeout. We can talk about those. So throttling is for prioritization, for giving queries. If you see and identify that the queries in the proxy layer that you want to go faster or make it slower, you can actually, there's some settings to do that. And the query timeout is also, of course, the application, network, database, they all have their own timeouts, but this is more customizable because you're in between the application server and the database server. You can actually set your own timeout depending on the scenario that you're using. This one example for this would be like if you're doing remote data centers, different time zones, different or DR implementations, this would be actually interesting to test it out for the timeout. Okay. So I'll go over this real quick. Then the manageability side, like I said, there's an admin utility. You can. It's not like just a invisible tool. So basically, once you set this up, you have a MySQL-like an interface, and you would actually set everything in there. It's very MySQL friendly, so everything looks like MySQL, and within the tool itself is like a MySQL shell. So it actually has the authentication support, and then we can basically, if you're going to that port to the database server, you can actually limit your users and the ports for that access. So there's a basically this adds an authentication layer to the database before you hit the database. So this might be actually a good idea for reducing number of users you have in a database, and then create a user that is actually needed to access over here, and then give access to those users only. It's just like a role management. You can actually do that over here. There is also runtime reconfiguration. There's a bunch of values that you can modify and edit, and then change those using that utility. And also monitoring is that's where all the data is collected and the monitoring is done. We might be able to show, if you go a little faster, we might be able to show some of those. Okay, so I'll switch to René.
All the use case scenarios that I'm going to present now, they are not hypothetical one, but they're actually all use case scenarios that are currently in production. And if you have any use case that for which you're using ProxySQL and I haven't thought about, just let me know. So again, those are all production setup. The first case is simple ways of when you have one application that connects directly to MySQL and the application has its own connection pool. And because the application has its own connection pool, it keeps open a certain number of connections to the database server. That can be 5 connections or 100 connections, doesn't matter. And this works quite fine in general, unless you have hundreds of applications, because now then you have a connection pool multiplied by the number of servers. So this results in a lot of connection to the database server. So one way to mitigate this is that you actually put ProxySQL in the middle, and now the application will create a lot of connection to the proxy, and you can have again hundreds of connections hundreds of applications that all connect to the proxy, but now the application can connect and disconnect all the time, but now the ProxySQL will only have a few connections to the database server. So it will also reduce the overhead of the application connecting and disconnecting all the time. Another use case is the use of the connection multiplexing. Again, this is another case in which every application has its own connection pool and they just create a huge number of connections to the database server. It is very easy to have thousands of connections here in MySQL. And there are some database systems that do not really scale well with a high number of connections. I mean, Aurora is advertising that can handle 5,000 connections. But I mean, nowadays 5,000 connections is very small number of connections. I mean, it's very easy if you have hundreds of applications that you could easily go beyond this threshold. So the way you can do it is, again, you put a proxy in the middle. Every application will have its own connection pool against the proxy. The proxy can have hundreds of thousands of connections, and the proxy will only have way less connection to the database server. Sometimes you can also have a ratio of 1,000 to 1. So you can have 100,000 connections from the application to the proxy, and then only 100 connections from the proxy to MySQL server. The proxy will reorder requests internally, so it will know which requests need to be served by which connection. Okay, next one. This is another very common use case. Use case is that, well, as Alkin was saying, you can have read-write split in the proxy. The way this is implemented is that in ProxySQL you define 2 host groups. One is the writer host group and the other one is the reader host group. ProxySQL doesn't know what is a master and what is a slave. It is completely generally replication agnostic. So again, it doesn't know that a slave is used for serve reads. You only have to configure that the servers in that pool, doesn't matter if they are slaves or not, they are being used for reads. And then you also configure the proxy to send all the writes to the master while it has to send all the reads to the slave. It can be either all the reads, and there's a very generic case. Most probably you are not going to use this solution because you don't want all the reads to go to the slave, because you might have, for example, the slaves that are slightly lagging behind. For some application, even 1 second lag is a lot. So the way I suggest normally is that you configure ProxySQL to send everything to the master, and because ProxySQL export metric, you can decide what should go to the slaves. And this can be done extremely dynamic. So you choose this query from now on is going to hit the slaves. And a good thing here is that ProxySQL is able to constantly monitor those servers and check for the read-only variables. And based on the server, based on this variable, if the server has read-only equals 0, it is put in this host group, in the writer host group. While if read-only is equal 1, it is considered to be a read host group. So the proxy will automatically move servers around. And yes, so the next, this is also useful for another use case, and I will show you later. So next one, how to do sharding. Sharding is a very complex subject, and I don't think there is universal definition of sharding. It really depends from your application's specific need and whatnot. So in ProxySQL, the way it's very easy to do sharding is creating matching criteria. So you define which traffic need to be selected and what to do with this traffic. One way of doing it is using the username. So you can configure the proxy that saying every time you're seeing a traffic from this user, it should go to one specific cluster. Otherwise, every time you're seeing traffic from a different user, it has to go to a different cluster. But again, in this cluster, you might have one master and slaves, so you can create way more complex setup. Like you can say, all the traffic from user A, that is a DML, goes to the master, while all the traffic from user A, that is a select statement, will go to this cluster, but on the slave, instead of going to the master. And again, you can apply the same principle with root, with user B. Okay. Here, you can also do sharding by schema, and this is even more easier because you can have your application that is only using one user, and again, this is a quite common use case. And you configure the proxy saying every time this application is trying to communicate with shard 001, it has to go here. Every time it's trying to communicate with shard 002, it has to go here, and so on and so on. And you can also have way more complex setup. And again, all this is in production. Like in this cluster, you will have shard 1, 2, 3, and 4. So you configure the proxy sayings every time this user wants to communicate with shard from 1 to 4, it has to go here. While every time you want to communicate from shard from 5 to 8, it goes to this cluster, and so on. And of course, because you can create multiple ways of matching criteria, the possibilities are infinite. Now, one solution that is not in production, but somebody asked about this one, is having sharding based on table name. And again, this is possible. So you can configure the proxy, forget about sharding by cluster, so you have for only one cluster, one master, and multiple slaves. You can configure the proxy saying all the DML go to the master, while the select statement for one set of tables goes on one slaves, while all the select statement on a different table go on a different slaves. Why would you want to do this? Any taker? Anyone who wants to try to bet why you want to do this? Considering that all the slaves will all have the same data. But this, all the slaves will have the same data. So they say yes.
Load balancing, slaves only have so much power each. So.
Yes, but why one set of table to one slaves, why another set of table to another slave?
A lot of data and limited amount of memory.
Correct. Yes. So if you have multiple slaves and one slave only handles a certain number of tables for reads, and this slave only serves read for that specific set of tables, it increases the probability that the data for that specific table is in the buffer pool. So even if it is replicating everything, it will speed up the select statement. Okay. Now failover. Okay, this is another important features. So assume you have your application, every application with its own pool of connection. They are connecting to the master, or they might also be connecting to the slaves if you already have read-write split. What happens if the master dies? No, okay. What happens if the master dies? The application will all get an error, say that the master has gone away, and then you promote this slaves to become the master, and somehow you need to reconfigure, or the application says, okay, this master is gone, now you have to connect to these new servers. Doesn't matter which tools you are using, you still have some delay for this to happen. I mean, and it's quite destructive because the application will all lose the connection to the database server. So you will get a bunch of errors. The way of solving this, the way is used. So you have ProxySQL in the middle, the application connect to the proxy. If the server dies, the application won't lose their connection to the proxy. So the application won't get an error related to the fact that the connection is gone. So it will still there. So here you might have MHA, orchestrator, whatever, that promote these servers to become the new master. MHA orchestrator can inform ProxySQL that a new master is present, or ProxySQL can detect itself, having the read-only variable. So it checks that this new server now has read-only equals 0, so it detects it says, okay, so now this server has become the master, and so now the ProxySQL will send the traffic that the application was sending to the proxy to the database server.
And in a case like this, you don't need anything like retarded or sync or anything. No. This will handle the whole situation.
Yes, correct.
And actually, this is why you make the minute agnostic to slave or master. It just goes by the read-only.
Exactly.
And orchestrator will handle it.
Yeah. Orchestrator. So because ProxySQL is completely configurable at runtime, you also can have orchestrator that tell the proxy, okay, forget about these servers, now this is the new one. Or you can have just ProxySQL that detect this. Why these features? This feature is useful if you have a lot of proxies and MHA or orchestrator does not know all the list of proxies. Because otherwise, if you are sure that orchestrator can communicate to all the proxies, you can just broadcast this message, you configure all the proxy, and all the proxy will know that there is a new server. But the problem is, if the list of proxies is dynamic, orchestrator might not know the complete list. So this makes configuration easier, because orchestrator has just to change the configuration in the database server, and the fleet of proxy will take care of the rest. Of course, it doesn't solve all the edge cases, because you can have network partitioning and blah, 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 but it works. Okay, yes, yeah. Oops. Another use case has been for DC migration. And sometimes you need to switch from on-premises to AWS, or vice versa, from AWS to premises, or from AWS inside VPC to not VPC, or vice versa. So there are cases in which ProxySQL has been used for this. So if you have the application connecting to one data center, or the database server in one data center, and you want to migrate somewhere else. Now, normally what you might have is some sort of downtime, because you have to reconfigure the application to start communicating with this new data center. And you need to ensure that all the application is actually communicating with this new data center, and no application, no application is still using the old data center. And this can become quite tricky, because you need to make sure that you have all the counting of all the application servers, and you don't forget any of those. So how ProxySQL was used? The way it was used that slowly all the connection from the application were migrated to ProxySQL. So who did this was ensuring that all the connection to the database server over time, they were only coming from the application, and from ProxySQL, and no connection were coming anymore from the application. Once ProxySQL was the only source of connection to the database server, now the flip was extremely easy, because it was easy to reconfigure one proxy or a couple of proxies. Says, okay, forget about this data center. Now the MySQL server is here. And so basically now all the application, in just one click, all the application are able to connect to the new data center. So this makes configuration, again, extremely easier, because you don't have to configure all the application. Okay, so I need to drink some water, yes.
What happened?
Thanks. So this was one interesting use case from Tumblr. So they have they are multi-DC. So they have database in they have database in one DC and database in another DC, and the application could be again in any data center. But for every cluster, there is only one master, and this master might either in one DC or in another DC. And so let's make things simple. I cannot share numbers, of course, but it says that there are only 2 DC and there were 50% each. So 50% of the application were in this DC, 50% of the application were in this DC. If the application has to communicate with the slaves, it is easy because it is in the same DC, very low latency. But if the application has to communicate with a master that is on the other data center, of course you have the network round trip. And the network round trip, you must have it anyway to execute the query. But their specific problem was that to execute query cross DC, they needed to have SSL connection, so encrypted. And their application was not very well optimized, so what happened was that the application was connecting, sending a few queries, and disconnecting. So cross DC, the cost of connecting, disconnecting, and establishing the SSL connection was way higher compared to executing the real queries. So how they solve this? So now, the application in every data center connects to a local ProxySQL, and this local ProxySQL knows if it is a reads, it will send the traffic to a local slaves, while if it is a write, it will send the request to the remote data center, but the connection between the proxy and the remote database, and the remote database in the remote data center, is always kept open. So the cost of creating new connection and establishing the SSL handshake is completely removed because the connection is already there. So the connection pool helped a lot for them in reducing the overall latency. And I know of others that are going to use the same approach for exactly the same reason. So cross DC SSL connection. Okay, so well, as Alkin already mentioned, ProxySQL is shipped with the Percona PXE, so it's part of clustering solution. And so yes, make things easy. If you're using PXE or Clara, and of course group replication is supported as well, but I'm not aware of anybody that is using ProxySQL with group replication in production right now, but it's possible. So with Clara, the way it works is that the application can connect to any of the proxy. The proxy will constantly monitor the status of the node. So you can have all the nodes that are all taking writes, or you can configure the node to have only one writer. And so in this case, the proxy will constantly monitor the status of the cluster and will detect when a node failed or when the writer has moved to another one. And again, the application is completely unaware that one of the server might have failed or it is in the sync mode, because if it is in the sync mode, of course, it should not be serving traffic. And again, the application should not know about this. The application is completely unaware. And the application, again, won't lose any connection if one of the server dies, and so on and so on. Query caching. Again, this was mentioned as well. It is very common to see, thanks. It is very common to see traffic sent to the database and the same query executed over and over again. And again, in my past was quite common to tell developers, you should cache this query. And said, yes, I will do it, maybe sometime, and it was never happening. So with ProxySQL has its own query cache, so you can actually configure the proxy says, okay, now from now on, when you're seeing this query, just start caching it. And the application won't even know that the cache, that the query is being served by the ProxySQL query cache instead of being served from the database server. All the application knows that it sends the query to the proxy and the proxy will reply. That's all. And of course, because you have the query cache, you assume that, of course, this is a select statement. If the proxy is able to cache those statements, probably you can also reduce the number of slaves you have. Because if you are scaling out, just because you have too many reads, if the cache can, the cache can also help you in reducing the number of slaves.
How frequent the cache gets updated?
Okay, how frequently? So every time you define what to cache. So not all the select, but you say, okay, this select that has this specific pattern need to be cached. And you also define for how long it need to be cached. So you don't have a way to invalidate the entry in the cache, but you only specify for how long you want it to be in the cache. And this is absolutely fine depending from your workload. Because if you are reading data from a slave, and you are okay with having outdate data for the specific query for, I don't know, 3 seconds, just making up a number, because the slave replication lag can be up to 3 seconds. So this means that you can configure the entry in that cache to have a TTL of 3000 milliseconds. The timeout is actually milliseconds, so you can be very granular. Okay. So yes, you can remove slaves. Query timeout. Again, if it is also very common to see queries that run on the database server for a very long time, and sometimes you just want those queries to go away. So you normally, what you will have some sort of query sniper. There is Percona toolkit that can do this as well. So you can configure that if you're seeing those type of queries, just kill them. But the query sniper itself is very generic. You cannot define exactly what sort of query you want to kill and what sort of query you don't want to kill. Instead of ProxySQL, you can create rules says that, I don't know, for example, you can say that all the traffic can be run with a maximum of an execution of maximum 3 seconds. Whatever run for longer than 3 seconds has to be killed. Or you can also say is that 3 seconds is your normal top maximum execution time, but then you would allow X number of queries, you define which queries that can run up to 5 minutes. Just making up example. So yeah, those queries will be allowed to run for 5 minutes, while everything else will be allowed to only run for 3 seconds. Everything that run longer, it will be killed. And of course, the application will be notified and will understand that something's wrong. Query blocking, again, this is a very interesting features. The feature what allows you to create rules specifying that certain type of query cannot be executed. Classical example, update statement without where clause, or select statement without where clause. And I know of somebody that actually went a bit extreme here, and he's using the query digest table in ProxySQL to understand what are the queries. And instead of having a list of queries that need to be blocked, he went for a list of queries that can be executed. So everything else is blocked. So he created the whitelist basically. They are a legal company, so they have very strict rules about what can be executed on the database server. So, and this is not the only use case. For example, it was 2 weeks ago, I had a sort of incident in which it was a regular traffic, so the application was sending traffic to the proxy, and the proxy was sending traffic to the database server. It was just a user that was sending a lot of traffic. The user has a lot of data and was really flooding the database server with a lot of queries. The owner of this infrastructure tried to block this user, creating some in their console administration, creating some blocking the user, basically deactivating the user. But still, for whatever reason, it didn't work. So the application was not able to block that specific users. So at the end, they said, "Okay, René, please just block in the proxy, and you just write the rules." And now, from that moment on, that user ID cannot execute queries anymore. Simple as that. And this is very useful if you are firefighting and you have some on-call issue. So you avoid that one single user is able to bring down your system. So you just block it on the fly. Okay, query write. How we are with time? Okay, perfect. So query write. This was one of the, as Alkin said, one of the very first features. is the ability of rewriting queries. The ability of rewriting queries can be as simple as adding a force index. And again, this is very common in my past when you understand, you analyze what queries are being executed on the slaves or on the master, and you tell the developers, look, this query is performing poorly. It's not your fault, it's the optimizer that is not using the right index. Can you please add the force index? And they will come up with answer, oh, I cannot do this because the ORM I'm using cannot have this force index. Or if they can, they will tell you that they have other priorities, or they will do it sometime in the future. While with ProxySQL, things becomes very easy. You just configure the proxy that every time you're seeing this type of query, just add the force index. Could be as simple as this one, or if, for example, if the application is sending some query with an order by rand, just remove that part. So it's very useful. And of course, the first thing you want to do is to save the database from being overloaded. And then you apply those changes, and then you ask the developers to actually fix it long term. Query retry. This is another interesting feature in my opinion. So let's assume that the application is sending traffic to the proxy is doing its own read-write split, query routing, etc., and is executing select on one of the slaves. And while it's executing the select statement, the server dies. So in a normal condition, if there was no proxy, the application will get an error that the query failed. While inside the ProxySQL, what can do is that it is able to detect that the query failed while it was running. It doesn't know why. If the server died or the connection was killed, it doesn't know why. But is able to re-execute the query. So again, the application won't get any error, won't know that something might happen, and the query will be automatically re-executed. It will just complete few milliseconds later, depending from how fast was the query. Query routing, I will skip this part because I briefly already spoke about it, about read-write split. And query mirroring. This is another very interesting feature. We have only 1 minute left, so what you can do is you can say the proxy that all the traffic passing through the proxy, or some very specific type of traffic, because again you can configure exactly what you want to select and to mirror, says, okay, now you can, all the original traffic or part of it, you can mirror it somewhere else. And you can mirror it as it is without making any changes, or you can also rewrite the query and execute it somewhere else. So this is very useful if you want to check that MySQL 5.7, your application is compatible with MySQL 5.7, while right now you are running MySQL 5.6, or if you want to know if a new set of hardware behaved better, or a new MySQL tuning behaved better than the original one, or you can also want to check if rewriting the query will improve performance. And you can check this one without actually rewriting the query that is currently being sent to production. Yes?
How do you decide which response you take then?
You only get the response back from the original one.
Okay.
The second one is discarded. Yes, it collects metrics, so you're able to check if the performance were better or worse, but the result set is discarded completely.
How about, what about the high availability for ProxySQL?
That's a completely different subject. Yeah. You have a lot of solutions, but this is not part of this session.
Have something in place?
Yes, it is possible. Yes, ProxySQL should not be deployed. The question was how to make ProxySQL available. In all this setup, or all this example, for simplicity, I only spoke about one proxy in the middle. Of course, there is nowhere in production one single proxy. So the solution is always high available, and I'm not going to discuss in this session how to make it high available because we just don't have time. But there are other sessions about this one. Yes?
When you do have multiple ProxySQLs, do they communicate with each other? To
Not yet.
There in sync,
Not yet. And this is another approach that somebody, so when we present this in Amsterdam, this slide was not here because nobody were using it in production, but now they do. So they have one proxy layer, in one proxy instance in every application server, and this proxy in the application server is communicating with a middle layer of proxies, and then this one is the one that is responsible for monitoring all the database server. Of course, you need to see this on a scale, so you can actually have 3 proxy, while here you might have hundreds of connections. And I think we are done with the time.
Thank you.
Thank you.